got interested in Bitcoin about 10 years ago. I spent a couple years organizing Ethereum meetups. But honestly, the whole thing around proof of stake and sharding was really just complicated. I could never quite understand the benefits or why we were doing this. And in 2018, I was fortunate enough to meet members of the Nervos team, and I got really interested in the idea of a proof of work smart contract platform driven by UTXOs, and thankfully I continued on this path of following Satoshi. So I think the first question we really want to ask is, what do we want from a blockchain? And I would hope by now, 15 years into Bitcoin's history, everyone knows that a blockchain is a trust machine. And in the dinosaur days of crypto, when we had, say, Dogecoin, Litecoin, Ripple, and there's not much else, trust really was the thing that people talked about. It wasn't TPS or smart contracts or ICOs or NFTs. It was just trust. This is what Bitcoin enabled. And the entirety of humanity, regardless of your political affiliations, where you were from, whether you were deemed a good guy or a bad guy, Bitcoin was something that we all could trust. And the only thing I can think of that comes close to this is something like gravity. Things that are not made by man, more like made by God or nature. And the important qualities in a system like this are censorship, resistance, and decentralization. If we didn't need these things, we could just use any existing web systems that are out there. If we weren't worried about humans interfering with what other humans were doing, things would be a lot easier and cheaper. But we know that's not the case. So this phrase, don't trust, verify, becomes very important. And it's one of the reasons I follow Satoshi. And I think it's important to appreciate the value of what a blockchain can provide. So for me, though Bitcoin's innovations are many, from a technology perspective, for me, it's really about POW and UTXOs. And that's what this talk will focus on. When we put these things together, we get a system with some very desirable properties. So the first thing is that proof of work is objective. Anyone coming online today can verify the history of the chain, and anyone coming online decades in the future could verify that the Bitcoin chain that they're seeing is the one with the most computational effort. It's also easily verifiable. Proof of work is really just the execution of hash functions, which are measured in microseconds, in terms of their execution. And this means anyone, anywhere with any device can verify Bitcoin. And for me, the math really makes this clear. So bear with me for a second. We've had about 834,000 Bitcoin blocks. Each block header is 80 bytes, but 32 bytes of that 80 is a reference to the previous block, so we get 48 bytes per Bitcoin block. And if you do the math, it's about 40 megabytes of data that needs to be downloaded to verify 15 years of Bitcoin's proof of work. Now, on an average 5G connection today, that would take about 2 seconds. And then maybe about another second to actually verify all those hashes. So this is so efficient that it's almost silly to sit here and do the math and figure out how long it would take. But when we think about things objectively, it's really important because this is the backbone of a decentralized system. Anyone can do this verification. And for reference, this is about what it would take to verify the signatures of a single block in Ethereum under POS. You also notice that when we're talking about these things, it's just hashes of data. There's no identities involved in this system. We're just checking data. We don't care who the miners were, where they were, how many there were, or what they were mining. It doesn't matter, and Bitcoin doesn't care either. And this quote from Satoshi Nakamoto has been in my head a lot lately. And it's of Bitcoin when he was releasing it to, or they were releasing it to the, I think it's a P2P forum. It's completely decentralized with no central server or trusted parties because everything is based on crypto proof instead of trust. So this is the essence of proof of work. So prior to Bitcoin, whether a currency was digital or not, it needed to have some sort of issuer or operator of a system. But a proof of work chain is really just math. We're all witnessing it and verifying it. And no specific person or groups of people are responsible for operating Bitcoin. We don't know who's going to create the last block, and therefore no one has the right to affirm the previous blocks. And what we consider the truth of Bitcoin is really just the convergence of all of us observing the proof of work and the consensus rules of the system. And this is something truly decentralized. It also turns out that this is an extremely efficient way to build a distributed system. So a miner finds a block, verifies that they've met the proof of work, then they distribute that block to other nodes who can quickly verify the proof of work, and so on. And to really appreciate the genius of Satoshi's invention, we can look at the domain of distributed systems prior to Satoshi, which were Byzantine fault-tolerant systems. Now, in a Byzantine fault-tolerant system, the entire consensus set needs to be known in advance. It needs to be public, specified, and identified. And this is stark contrast to Satoshi's anonymity. Also, the system can only progress when 2/3 of the nodes confirm a state transition. Also very different from Bitcoin, where you just need one miner to find a block and the system can progress. And additionally, finalized transactions cannot be rolled back. Once 2/3 of nodes have confirmed a state transition in this kind of system, nothing can change. And if there was any error in what was confirmed by those 2/3 of nodes, that's a catastrophic failure of the system. Now, we've already seen in at least one example that Bitcoin needed to be rolled back because of a consensus bug. And at any time, the history of Bitcoin can be rewritten. So it's a very robust system that can respond to problems like this. And proof of stake resembles Byzantine fault-tolerant systems much more than it does proof of work systems. And we've seen various examples of this exposed. So Solana is, I think, the most well-known example of problems with the proof of stake system. It's been down 10 times now, which I had to look this up. I couldn't believe that, actually 10 times how many times Solana's been down. And this is because of this 2/3 agreement required to rest the chain. If you don't have enough nodes running software that works, then the system will just stall. Additionally, there was a bug found in an Ethereum client, I think about a month ago. It was Nethermind. It was a minority client, but the concern that came up was the idea that potentially an invalid state transition could be finalized in Ethereum because more than 2/3 of validators run Geth, and if there was ever a bug in Geth, then that chain could get finalized. And this would be a catastrophic failure of the system. So short of a hard fork to correct this, you would have massive slashings of stake. And beyond just these clear differences in how consensus works, the efficiency of the system is also very important. This is the kind of nightmare that Byzantine fault-tolerant systems gave us, and the kind of thing that people would joke about prior to Satoshi coming around. Researchers have done a lot to optimize these things under proof of stake, but there's still fundamental limits. If we look at Ethereum, 2/3 of stake is typically required for a block to be finalized. And this seems reasonable at small scale, but when we get to a global scale of a decentralized system, the number of validators grow, the verification overhead grows, and this gets unreasonable quite quickly. And we've even seen Vitalik propose limiting the size of the validator set because of this paradigm. This has to do with quite complicated things, but he does propose limiting only 8,000 validators per signature per slot. Additionally, Solana, you can see here 140,000 compared, or 1.4 million. There's an 80-20 relationship here between the transactions that are needed for Solana to come into consensus compared to the actual transactions that it's coming to consensus on. So there's a huge amount of overhead just coming from this idea of proof of stake. So how I've been able to formalize this is that in a proof of work system, it's expensive to produce consensus. You have a lot of miners consuming a ton of electricity around the world, but it's cheap to verify. We can all very quickly verify Bitcoin's proof of work, as I just showed. Conversely, in a proof of stake system, it's cheap to produce consensus. We can all produce millions of signatures on our phone right now, but it also gets very expensive to verify. And I think this goes to the heart of questioning what is important in a decentralized system. And for me, it started to look like this paradigm comparing horizontal and vertical scalability. So if we think about POS chains, they're relatively easy to bootstrap. We could all start a POS chain in this room if we wanted to. There are literally thousands of them. However, due to this idea of signature checking and 2/3 confirmation, they should have relatively small consensus sets. These systems scale by scaling out, adding more chains. And I think the Cosmos ecosystem is probably the best example of what scaling POS systems looks like. However, POW on the other hand scales up. A POW chain is very, very hard to bootstrap, but we can add as many miners as we want without increasing the verification overhead for all of us. While we're on this topic of vertical scaling, I want to talk about the other important innovation of Bitcoin, and that is UTXOs. So with them, we effectively get a system with a sharded state. I know Ethereum was all about sharding, it never happened, but UTXOs are effectively a sharded system. Each coin is unaffected by the other coins in the system, so a user can easily find transactions that they care about and only worry about them. So with this capability, the blockchain can scale up through light clients, in which users are only checking the proof of work very quickly, like I already covered, and then just syncing blocks that have transactions relevant to them. So they can construct their own transactions, and they don't need the help of third-party RPC or node providers. And this design also opens the door to client-side validated protocols like RGB, as Cypher was just talking about, as well as channels and partially signed transactions, which also can scale the throughput of the blockchain. UTXO systems also have much lower hardware requirements for running a node. UTXOs provide the same kind of cryptographically authenticated global state, just like Ethereum, but they do so without the expensive computation processes that Ethereum requires to do so. And thus, big SSD drives, like very few of us have in our laptops, are not required to run nodes. Users can run nodes with flash drives or old spinning drives if that's what's most convenient. And with this, we get a network where we don't have specialized hardware or cloud environments required to run nodes. Basically, anyone can run a node in a UTXO blockchain. And with CKB, this is a key design consideration. So, I want to revisit why Bitcoin equals trust. So first, participants in the system verify the history of the system. And they interact directly with the network, whether that's through running nodes or using light clients. Intermediaries can't lock them out. And all they need is internet access and to find other nodes in the system. And a last point that's very important about this idea of trust is that there's a cost to consensus in Bitcoin. And this creates a balance of power between nodes and miners. Miners need to create blocks that nodes will accept. Any miner who's not following the consensus rules of the system is just wasting their time and resources. They're directly hurting themselves. So good behavior is directly incentivized without the complicated, crazy mechanisms that we have with proof of stake. This also attaches a real cost to forking. So if you think about the event of Bitcoin Cash a few years back, there are miners that incurred very significant costs because of their decision to support that fork. In proof of stake, you really only have to line up the political connections to enough stake to change the rules of the system. Okay, I know I'm wearing a CKB shirt. I'm sure there's some people that wonder about CKB. But there's one last thing I need to get to about UTXOs. And that's, in Bitcoin, there is no standard transaction authorization logic. It's completely open-ended. Whether that's a native multi-sig or a time lock wallet or something new like SegWit or Taproot, new functionality can be added at the base layer without affecting users that are already using the system. Now what about CKB? So CKB generalizes Bitcoin with the aim of building a system that is just as decentralized and robust, but increases the flexibility of it with a RISC-V virtual machine that can verify any computation. So in the context of account abstraction, this means using any wallet, any cryptography can be used. We've seen developers implement quantum-resistant lock scripts, passkey wallets, wherever Cypher went, and Ethereum wallets, as Frank is sitting here in front of me. And the possibilities really are endless. With RGB, the RGB++, the team is going to use SPV proofs of a Bitcoin transaction to unlock a UTXO. It's unheard of on other blockchains. The core team has implemented Taproot support, and any of those cryptographic magic ideas that people have dropped on the Bitcoin mailing list over the years can be easily implemented on CKB. Additionally, covenants. CKB natively has covenants. They're called typescripts, and these can be used to implement logic governing both the inputs and outputs of a transaction. You're really only limited by your imagination with CKB. We've seen support for different interpreters, for different programming languages, sparse Merkle trees, MMRs. CKB is really freeing for a creative blockchain developer. Last year, Fly Client was implemented, and we've seen a huge uptick in users using Neuron, the reference node wallet, because now it's a light client wallet and they can sync in a few minutes. Additionally, the CKB consensus protocol, NCMax, wherever Ren is, maximizes the bandwidth utilization of Nakamoto consensus with adjustable block intervals based on orphan rate and a two-phase commit process. Additionally, size of state is bounded. I know state rent and running nodes has become a topic of conversation now. For CKB, it's been an important thing for years now. So the amount of data required to run a node is limited. In closing, Satoshi invented a permissionless, leaderless distributed system for the first time ever. And I'm happy to say that CKB has taken the long path for a smart contract platform and has been created to imitate Bitcoin in as many ways as possible, while trying to create a new system a new programmable blockchain that can secure systems built on top of it. CKB has been live since late 2019. I know a lot of people are just learning about it for the first time. There's a vibrant community of enthusiasts, tinkerers, and miners. I look forward to seeing what all of us can build with Bitcoin and CKB together. If you're interested, I encourage you to run CKB. You can check out these ideas formalized in an article on the blog, and also these other links for CKB. Thank you all, and enjoy your afternoon.